Welcome. Thank you for joining us. I see we have lots of members from our industry just slowly coming on. On behalf of the NBDA, we cannot thank our association members, retailers, and our deep membership base enough for continuing to show up to these important events so we can learn and better our business practices. Electric bicycles have become the fastest growing segment of the bicycle business. And this development is changing the face of conventional bicycle retailing. So forward-looking bike shops have embraced the sale and service of e-bikes as an important and profitable aspect of your business. But just as gas stations take special safety precautions to minimize the chance of uncontrolled release of energy, fires, so too must bike shops take these same safety precautions with the maintenance, storage, and delivery of lithium-ion battery packs used to power the e-bikes that they sell and service. As you saw the recent news in bicycle retailer, People for Bikes has partnered with Call to Recycle on the industry-wide battery recycling program. And now more than ever, as we move forward, safe storage is an important component of our operations. In today's presentation, we partnered with the Professional Bicycle Mechanics Association. They will first present results of an e-bike best practices survey that they recently conducted of their members. And then Human Powered Solutions will offer observations and present safe lithium-ion battery storage and charging procedures for your bicycle store. We encourage all questions, and you can put them in the chat function as we go along. And then at the end of the presentation, we will do a question and answer session. I'm joined here today and would like to give a warm welcome to both Jenny Callista, the president of Professional Bicycle Mechanics Association, and Mike Fritz, the chief technology officer with HPS. Thank you guys both for partnering with us. I just want to kick off with some general introductions. Jenny, might you tell a little bit about the PBMA and yourself?
Sure. So I'm Jenny Callista. I'm the current president of the Professional Bicycle Mechanics Association, which we founded back in 2016. We're doing our best to make lives better for mechanics. That's kind of the underlying goal always with what we do. And otherwise, I am an educator. I have a school for bicycle mechanics that I've had since 2010, Appalachian Bicycle Institute.
Yeah, thank you, Jenny. It's been great working with you on this project, and I hope we continue to work closely moving forward. Mike, I'll just throw it over to you. Would you introduce yourself and your role at HPS?
Be happy to. Thank you, Heather. My name is Mike Fritz, as Heather has mentioned. I'm Chief Technology Officer at Human Powered Solutions. Human Powered Solutions is a relatively new consultancy. I think we've been together for about 3 years now, and it's comprised of a number of old Schwinn bicycle veterans. We go way back at Schwinn, so there's a lot of collective experience and expertise associated with bicycle business. Jay Townley is a founding partner. Brad Hughes is a founding partner. I'm a founding partner. We've involved Dave Carnabogue and Dan Garamoni. Again, all Schwinn execs that were there when Schwinn was a family-held company, but was profitable and successful. We've all gone our separate ways over the years to various other bike companies and endeavors, primarily focused on the industry. In my particular case, I transitioned into electric bikes in the mid-1990s when I was hired by Lee Iacocca to be his vice president of engineering and product development for EV Global Motors. That was my entree into e-bikes. So I've been doing it going on 25 years, everything from sourcing to engineering, product development, with a particular focus on propulsion systems, motors, batteries, displays, sensors, etc. So I've got quite a few years under my belt of expertise and involvement in these fields, which I feel qualifies me for having this conversation today and offering to you my advice relative to safe practices as they relate to battery charging, battery storage, and whatnot in the e-bike retail environment.
Mike, I was thrilled to meet you. I think we first met in person at the Cabda Midwest show, and when Jay was introducing myself to you, and just your passion around the safe storage of these batteries and how we can help educate retailers was overwhelming. And thank you for your continued drive. I know you spent a lot of time researching to bring some really great, valuable information today, so we can't thank you enough for that.
anything that we can do. I mean, the purpose of our consultancy is to promote cycling, promote electric cycling, and to do it profitably and safely to the benefit of everybody.
So we partnered and we reached out to Jenny, and Jenny, you've just been great putting together this survey to survey your members about what their knowledge is to date and their best practices that they're doing at this point. Jenny, do you mind if I just turn it over to you to share the results of that survey, a little more about that survey with our listeners today?
Sure, you bet. So we thought it would be interesting to see where everybody is at with understanding the safety protocols that we're concerned about here. So I'm going to take a look at opening up my survey results here. So we sent this out, I guess it was a little over a month ago or so, and we didn't get an overwhelming response from people. Just under 60 people responded, but it was a pretty common thread that we saw that not everybody is thinking about this. So our questions were, do you have any clearly defined protocols for handling e-bike batteries? Let me see if I can't share this. I apologize. I'm not the most Zoom savvy. It's not something that's required in my normal line of work here. I don't know if I'm going to be able to do this, but do you have any clearly defined protocols? Just over half the respondents said no. So over 54% people said no. Does your protocol involve mitigation plans in case of fire? Again, close to 60% of respondents said no. Do you share best practices for battery charging with your customers? Most people do that. Close to 70% of folks share that. And then the fourth question, are batteries charged in an intended area? Most people, close to 80%, do that. But this is where we saw kind of the most, I guess, alarming, and that's why we're having this discussion here, is last questions. Are batteries stored in a fireproof, vented to the outside cabinet? Over 90% of people said no. So unfortunately, that really kind of doesn't bode so well for how people are truly, safely storing these batteries. So, again, it really kind of shows where we're at with all of this. Yeah, it's surprising in a way, but also I guess not, because this is all pretty new, yeah. So that's what we've got.
Yeah, thank you, Jenny. And I know when we were all looking over the results, I think we kind of anticipated that that's what we would see, but it just gave us a little more fuel to be like, all right, we need to put this together and we need to get this information out to retailers as soon as possible. The number of fires just in New York City alone, and I think Michael probably touched into this, but it's just overwhelming and we do need to address it. So Jenny, thank you again so much for working with the NBDA on behalf of getting this information out and surveying our retailers. Mike, I guess I'm going to turn it over to you for observations, findings, and guidelines.
Certainly. Thank you, Jenny, and thank you, Heather. Let me just talk about one additional qualification that I hold, again, to talk about this stuff is since the ICOCA days, as I mentioned, I've worked for e-bike propulsion system related companies. And among the companies I've worked for and the clients I've had, I have worked directly for battery pack suppliers to the e-bike industry. I've acted as the North American technical representative for a couple of those different companies, and as such, I've been trained in aspects relative to the manufacturing, production, development of e-bike battery packs, and their integration into electric bicycles. So, and unfortunately, one of the responsibilities that I held in those roles is sort of as a forensic investigator, because unfortunately there have been battery fires, as Heather alluded. They are occurring with increasing regularity in New York City. And New York City is unique in a sense that if you've been there recently, the literally clouds of delivery bike riders riding electric bikes crowd the streets in New York City. So the adoption of e-bikes in a commercial role is probably happening in New York City faster than it is anywhere else. And as one would suspect, with that number of bikes under heavy usage in a major metropolitan area like that, the frequency of fires is high. So, and as I mentioned, I have been involved in investigating fires. So I've worked with forensic laboratories across the country on diagnosing and analyzing the cause of those fires. The bottom line is there's a lot of experience in this particular aspect of the industry. But one thing that I want to state clearly and upfront to everyone that's listening is that we do not want to convey the message that e-bikes are dangerous, because e-bikes certainly are not dangerous. They're an introduction into the transportation infrastructure that will benefit us all, not only from health and fitness standpoint, but from climate change, et cetera, et cetera. This is just one aspect of lithium-ion batteries that needs to be addressed. We need to be aware of, and that's not to say that this is going to be with us forever. There's a lot of engineering and technology research going on right now to eliminate this particular characteristic or attribute of lithium-ion batteries. There will come a day in the relatively near future when we don't have to worry about that, but we're not there yet. So without further ado, let me start the presentation here. What I'd like to do is just give a brief introduction to the history of lithium-ion batteries. They were initially introduced in 1991 as a high energy density but low power density electrical storage device. And what that means is high energy density means that a lithium-ion battery can store an incredible amount of energy for its very small size and lightweight. Heretofore, it's the best, most effective high energy density storage medium that we have at the present time. And that has made it suitable for a number of different applications. Initially on handheld electronics. You can power your cell phone for a complete day based on the energy that's stored in a lithium-ion battery. Laptop computers, now Apple's introduced new computers that'll get I believe up to 15 hours of usage based on the energy that's stored in their lithium-ion batteries. But the important thing to note is that these batteries are low power density. What that means is, in spite of the fact there's a lot of energy in that small package, you can only extract it slowly. And in a handheld electronic device, that's not a problem because they don't use a lot of current. They don't draw a lot of energy from the battery to sustain their function. A vehicle, on the other hand, requires a high energy density, high power density lithium-ion battery. And that was not the case years ago. They've only been developed recently as the battery industry realizes that this is a huge opportunity to power electric vehicles. But electric vehicles demand high power. It takes a lot of amperage to accelerate an electric vehicle to a useful speed for a useful range. And the advantages are obvious. They're very lightweight. You could not, if it weren't for lithium-ion batteries, there would be no Tesla right now because you could not cram enough lead-acid batteries in a Tesla to give it more than 100 miles range, and the thing would weigh as much as a semi-truck. So this has really been the breakthrough in energy storage technology that's enabled us to do the widespread development of electric vehicles. And that's tremendous. But any kind of energy storage is risky, especially high energy storage. And, because the uncontrolled release of energy is dangerous and can have catastrophic consequences. I mean, we can all imagine what would happen if somebody tossed a lit match into a bucket of gasoline. That would be an uncontrolled release of a lot of energy, and it would be a pretty serious consequence. But through engineering and technology, we've managed to harness the energy contained in gasoline. We will park our cars in our garages right underneath our bedrooms without a second thought. We do it every day because we've managed to engineer safety devices and mechanisms that contain the energy in a tank of gasoline. Obviously, if a car is involved in an accident and the gas tank is ruptured, you've got an uncontrolled release of energy, but the tanks are so robust now, that's not a big problem. Lithium-ion batteries also represent the risk of uncontrolled energy release. There are certain mechanics, if you will, associated with the failure of a lithium-ion battery, and the consequences of that can be very serious. But significant progress, as I alluded a minute ago, there's significant progress being made to put that genie back in the bottle, as it were, to address those safety issues. The primary development that I'm counting on, that I think has got the most likelihood of being successful, is what we call solid-state lithium-ion batteries, wherein we replace the liquid electrolyte, which is the flammable component of a lithium-ion battery, with a solid-state material. And not only will these be safer batteries, they'll be the safest batteries, but they'll also have higher energy and higher power density, which is a win-win situation. But we're still probably 5 to 7 years out before we'll see the widespread commercialization and distribution of solid-state lithium-ion batteries. So in the meantime, battery fires do still occur. They don't occur often, but they do occur. And it's incumbent upon us, the people that deal with these batteries on a regular basis, to make sure that we implement the proper procedures and protocols and preventive measures to minimize the ramifications of this attribute of this energy storage mechanism. The whole focus of this, obviously, today is the safe lithium-ion battery safety in the retail environment. But this is the point that I want to make most strongly. If you come away with one thing from these conversations today, it's the fact that the chances of a fire in your shop are minuscule. I don't know what the statistics are, but it's very, very low. But the ramifications, the consequences of fire in your store can be so significant, so dramatic, that the simple steps that I would like to convey to you today are more than justified. There's some expense involved, and there's some discipline, if you will, involved. But believe me, it's cheap insurance in terms of what could happen in the event that a battery fails and results in a fire in your shop. As far as I'm concerned, there are basically 4 key elements to ensuring that your shop is taking all the steps necessary to make sure that you will not have a very unpleasant result in the event that this occurs. One is the appropriate equipment. There's certain things that I'll recommend today that I feel are essential to make sure that if anything does happen, that the effects, the consequences are mitigated. We need to have comprehensive training for all your shop employees. Everybody in the store needs to understand that when you're dealing with lithium-ion batteries, certain precautions must be taken. This is not optional. This must be done, again, to minimize the chances of an unpleasant experience. There needs to be strict adherence to the established procedures. There can be no exceptions. It's an exception if somebody doesn't follow the rules and a battery cell fails leading to a fire, then it's too late. This needs to be done on a regular basis, and it's important that the shop management understand this and make sure that these protocols are followed unwaveringly. Required equipment. This basically is what I believe are the minimums that you need to have in your shop. A fireproof cabinet. It's a component that's readily available. You can find them at any industrial supply company. I actually bought one from Amazon.com. Obviously I deal in e-bikes a lot in terms of product development. I've got a garage full of e-bikes. I've got a number of battery packs in my garage, but they're all stored in my cabinet unless I'm working with them or test riding. It would be important, if it's feasible, to vent the cabinet to the outside. That's because a lithium-ion battery generates a lot of toxic smoke and fumes. And if you can vent this to the outside, so much the better. If you can't, what I do, I'm in a rented house and I can't punch a hole in the side of my garage. So what I've got a 2-wheel cart right next to my cabinet. If there were to be a fire in my cart, I would tip the cabinet back, put the 2-wheeler underneath it, wheel it out onto the driveway, and call the fire department. We'll talk about the actual steps, though, in a few minutes. But clearly, this needs to be stored away from cardboard or any other flammable materials. If there is a fire, the cabinet will contain it, but you want to make sure that there's no chance of that fire propagating, so it needs to be stored in a safe place. Additional requirement, a wire-style battery rack. This is, again, readily available. Costco sells them. You can walk into a Costco store and buy it off the shelf. as I say, readily available, preferably with wheels on it. I maintain that if you've got a number of battery packs on that rack being charged and one of them fails, it's pretty easy to roll that thing to the door and roll it out of the store and again, call the fire department to deal with it. The good news, the other benefit that a wire rack charging station has is the fact that that allows air circulation around the pack and the charger. And it's always good to try to keep those packs as cool as possible during charging. It's just an added side benefit. And if there were to be a fire, then the metal won't burn. And that gives you a little bit more time to deal with a pack that's failing. What I like to do is I'll fix the chargers from the manufacturers to the chart with zip ties. If I had a retail environment and I was buying a particular brand of bicycles, I'd buy a half a dozen additional chargers over and above what come with the bike that they're ultimately delivered with the customer, so that you can always deliver a brand new charger to the customer, not one that's been used for charging a bunch of batteries over time. And positioning, tying them to the rack is good practice, just to make sure that you've got the proper charger for the proper battery at any given time readily available, because what you want to do is charge the battery pack before you deliver the bike to the customer. And finally, I'll zip tie a power strip with an on-off switch to the rack and connect all of the chargers there. That way you've only got one line of feed to the chargers, and that's the power strip that could be easily disconnected if in the event you found that you needed to move the rack outside in case of an emergency. Just common sense thoughts, common sense practices. But the important thing, and this is one of the protocols that need to be enforced in the shop, is that this is the only place that your batteries are charged. You don't want to put a battery pack on a workbench, for example, and charge it there, because in the event of a fire, if it's a wooden workbench, there's an opportunity for propagation. And so charging every battery pack on the rack needs to be one of the rules and regulations that you implement in the store and strictly enforce. Additional equipment, trash can, 32-gallon trash can that you can buy from any hardware store. I service batteries from time to time. I've been trained by the battery companies to service battery packs. It's not unheard of that during servicing a battery pack that you inadvertently cause a short circuit, which will lead to a cell cooking off. I've got one of these buckets right next to my workbench. It's 3/4 full of water. I took a chunk of a chlorine tablet used in a swimming pool and put it in there to keep the water relatively fresh. But if I were working on a battery pack and I short-circuited it and caused a cell to go into thermal runaway, I simply dump it in the pack. The idea here is that if you're familiar at all with the construction of e-bike battery packs, they're what I call a serial parallel matrix of 18650 or 2600 lithium-ion cells. And by serial parallel matrix, I mean the cells are joined in parallel to accomplish the capacity requirements of the battery pack. And then those parallel strings are joined in series to achieve the requisite voltage, either 36 or 48 volts are most common. That means if you've got a battery pack that is say a 14S 5P, which is relatively common in high performance bikes, there's 70 cells in there. If the pack fails, it will start with a single cell. And that single cell, once it goes into thermal runaway, it cannot be stopped. But what you can do is you can prevent propagation. And that's the purpose for this garbage can. You dump it in a vat of water, the one cell will continue to burn. The water will not put it out, but the water will cool the adjacent cells. And what that will do is prevent that fire from propagating in the battery pack. So having a bucket like that, in the event that a battery pack starts going into thermal runaway, dump it in the water. It will not stop the one cell from burning, but it will stop propagation of the fire to prevent additional damage. The reason that I recommend the 32-gallon container is that it will accommodate most pack sizes. Nowadays, e-bike developers are developing all sorts of interesting geometries for battery packs to fit in the down tube, or battery packs to fit on a rack, or battery packs that are attached to the water bottle studs. This will accommodate anything, and with sufficient water in there, it'll be totally immersed in the event of an emergency, and will go a long way to preventing a more serious event. The other thing is smoke detector, obviously. And the optimal would be a smoke detector that's wired into a network security system, so that if in fact a pack does start smoking, number one, it's going to draw your attention to it so that you can react and do whatever's necessary to mitigate the occurrence. But the other thing is it will automatically call the fire department. And in any case, if you see a battery pack entering into thermal runaway, it's not a bad idea to get the fire department on the horn and have them come just in case your mitigation efforts aren't successful. And then fire extinguishers. Fire extinguishers, the only reason fire extinguishers are important is in the event that something adjacent to the battery pack catches fire while you're trying to control the event. Fire extinguisher will not put out a lithium-ion battery fire. All you can do is have that handy in the event that it inadvertently spreads and you want to contain it to the battery pack. Additional things, obviously, is you want to mount that near the charging station. The protocols, this is what's important. If I don't, the second thing I need to get across to you today that you need to take away from this is the fact that you never, ever charge a lithium battery unattended. The fires have occurred when batteries are put on chargers overnight and the shop is closed. If there's no one there, there's nobody available to take the necessary steps to mitigate the fire, and the consequences will be severe. This is probably the single most important rule that you can implement in your shop. Only charge batteries when the store is open, the store is manned, so that somebody can intervene in the event that a fire occurs. This is also an important point to make with your customers. You know, here again, just common sense. You don't want to charge these things where somebody's not available to intervene in the event that there's an issue. Batteries most often fail during charging. This is just the reality of lithium-ion battery failures. They most often fail during charging. If they do fail, you've got to intervene. The good news, if there can be good news under this, is these things they communicate to you the fact that they're in the process of failing. They'll make popping noises. You'll see smoke emitting from the battery case. In some cases, again, if it's a single cell, the localized heat is so much that it will melt plastic of the case. So it's not something that transpires suddenly. There's a lot of warning indications that something's going wrong here, which gives you time to intervene safely. Clearly, you wouldn't want to interact with a battery pack that was fully engaged, but this is the important thing to note. If there's somebody there while the battery pack's on the charge, you can do something about it if it starts to fail. This is the whole point. Immediate action can be taken. These are the specific protocols that I recommend. Store all battery packs in a fire-resistant cabinet unless the bike is being tested or you're preparing it for delivery. I get asked a question a lot of times, well, what if I have rental bikes in my store? No problem. Have the batteries on the bike so that you can easily and quickly demonstrate it to an interested customer. But when the shop is closed and it's time to go home at night, pull them off the bike and put them in the cabinet. Don't leave them sitting out overnight, and certainly don't charge them overnight, because that's when the biggest catastrophes can occur. Second thing is when you receive new e-bikes from the distributor, immediately remove the e-bike batteries from the bike box and store them in their own packaging in the cabinet. Don't leave them sitting in the bike with the box for the reasons that we've discussed. Pull them out and put them in the cabinet. Every battery in your shop should be in that cabinet unless the bike is getting prepared for delivery or you're working on it. Don't pre-charge new batteries. You know, if a new bike comes in and you pull the battery pack out and you charge it, all you've done is put more energy in there. That if it's involved in an uncontrolled energy release, that's more fuel for the fire. So don't pre-charge them until or don't charge them until you're planning on delivering it to the customer. Store batteries from e-bikes that are brought in for service. Somebody brings a bike in to change a flat or for a tune-up. If you don't get to it right away, pull the battery pack off, put it in a cabinet. Don't leave it sitting on the bike until your mechanic can get to it to do whatever service he's going to do. The bottom line here is don't allow any lithium-ion battery in your shop to be stored outside that cabinet, because in the unlikely chance that something happens, it'll be contained. And finally, don't charge battery packs in the cabinet. It would be a pretty sorry situation if you were charging a battery pack in the cabinet, it failed and burned up the rest of the batteries in the cabinet. And that would be a significant fire, because each one of these things contains a lot of energy. Additional storage protocols, only charge the batteries on the charging rack. I made that point before when we were talking about the pack. Don't charge it on a workbench, charge it on the rack. Use only the charger that was supplied with the battery. I don't mean the one that came in the box with the bike, but the standard charger that you purchased from the brand ahead of time as an extra. But don't charge a battery with any other charger other than the one that is intended for use with that particular battery. I've heard of people using a power supply to charge a battery pack. That's a no-no. You don't want to do that. Don't try to use a charger from a different company. Generally speaking, engineers for the various companies will develop a unique connector so that you can't use anything but the intended charger. But in the event that by coincidence one company's got a connector that's compatible with another company's battery, don't interchange them. Only use the battery charger that is intended for that particular battery. This is my point. Never charge with a power supply or a charger that wasn't intended for that pack. When the charger indicates that the battery is fully charged, when that little LED on the pack turns from yellow or red to green, unplug it from the wall, unplug it from the battery, put the battery in the cabinet. You know, unless you're delivering the bike, in which case the customer will take it. In case of emergency, these are my recommendations for what to do in the event you do experience a failing battery. If the battery starts smoking, making noise, or shows melted plastic, if you can do so safely, you know, obviously if it's well along in terms of its failure and the pack is not safe to handle, get it outside one way or another. If it's on the charging rack, roll the charging rack out. But if you can, pick the battery pack up, disconnect the charger, and drop it in the bucket of water. What you'll do is preclude propagation from one cell to the other. Again, in a pack, only one cell will fail, but its thermal runaway will quickly engulf the other cells, adding fuel to the fire unless you can stop it with the one cell, and that's what the bucket is intended to do. Now, there have been some discussions about the fact that lithium-ion batteries in thermal runaway react in unsafe ways with water, generate hydrogen gas and whatnot. But again, we're only talking about one cell here, one small cell in the scheme of things. So the bucket of water, any disadvantage associated with using the bucket of water is offset by the fact that if you can stop that thing from propagating, from spreading, it's a good thing. Call 911. It's, you know, that's clear. In the event that you've got a problem starting, even if you can control it, it doesn't hurt to have the pros on hand just in case it doesn't. You've heard the stories about Teslas being involved in accidents that breached the battery case and caused the batteries to be damaged and go into thermal runaway. And the fire department will work real hard to put the fire out. And 2 hours later, it'll restart because there's still energy in those cells and there's still mechanisms by which they can fail. So call the fire department, get the pros on the scene as soon as you can. They'll know what to do. If the battery pack is on the charger, this is what I alluded to a minute ago, and it starts, wheel that cart, you know, disconnect the power strip, wheel the cart outside, and, you know, obviously if you can, pull any additional batteries that are on the rack that are not involved and get them in the cabinet, but get that failing pack outside where it's not going to do any more damage other than become an attraction for bystanders. And as I say, if you can get any other batteries that are on the chart off that cart and into the cabinet, that's a good practice. If any of these steps are not possible for whatever reasons, the next best thing you can do is evacuate the store. As I say, lithium-ion battery fires generate toxic gases. You don't want any of your shop personnel or your customers to be affected by that. Get them out of the store, and hopefully by that time the fire department's on its way. Just some notes on the realities of a fire. It's not possible to extinguish. So I say is these steps are intended to mitigate. You're not gonna put it out. You're gonna try to minimize its propagation. Initially from cell to cell propagation, and beyond that, you know, to any flammable materials that might be available. You want to control it. You're not going to stop it, but you want to control it. And the earlier you get to it, the better. And this also underlies the rule that says never charge a battery unattended. Once the cell enters thermal runaway, it's not going to go out until its fuel is consumed. That's the reality of these events. And as I say, the best strategy for mitigating the fire is preventing that cell to cell propagation. And that's why we recommend the bucket. Just said that. And as I say, it's your best recourse here is to get the battery pack outside on a driveway. And in all likelihood, once the fire department gets there, all they're going to do is let it burn itself out. Once propagation has occurred and more than one cell in the pack is engaged, the only thing you can do is let it burn itself out, because generally speaking, once the cell's in thermal runaway, it's not going to go out until it exhausts its fuel. This is the point I made a moment ago, that these things generate extreme heat and toxic fumes. I've got photographs of aluminum bicycles that are literally melted. The heat from a lithium-ion battery pack will melt a frame. It's that hot, and the smoke and soot and fumes that they produce are dangerous. Best recourse is to evacuate in the event you can't mitigate it. That's pretty much my planned presentation. And again, I cannot say this enough. The chances of you experiencing this are very, very, very small. Most dealerships will never experience one of these failures. But if you do, taking these steps, being prepared for it, being prepared for it, being prepared for it is the best strategy. You don't want to bet that it's not going to happen to you, because if it does, the consequences are severe. Be happy to entertain any questions. I had considered at one point to discuss in more detail the mechanisms of battery pack failure, but I think that might be too technical at this point. So let's just leave it with our recommendations for preparing for it.
Mike, this was a fantastic presentation, and we did have a lot of questions come in, and they're kind of all over since they were put in as you went along. So I'm just going to kind of start at the top of the questions that came in. What charging recommendations should we offer e-bike customers who will not purchase charging station accessories or large trash cans full of water?
And again, it comes down to statistics and chance. The reason we think this is important for an e-bike shop is because a lot of battery packs are going to run through your shop on a regular basis. More packs in your store, the higher the likelihood that something's going to happen. Very unlikely globally, but the more packs, the higher the chances. The chances that a customer is going to experience a fire is even lower, because they only have one battery. But the main rules that say never charge it unattended apply. I investigated one fire up in Minneapolis where a consumer had taken a battery and put it on his kitchen counter and charged it overnight because he was going on a trip the next day, and it failed. And the damage to the kitchen was severe. Fire department got there in time to prevent the house from burning down, but they put it on a charger and went to bed. Not a good idea. Monitor the battery pack as it's being charged. If something occurs, something doesn't seem right, get the pack outside and call the fire department.
So is it fair to assume that e-bike batteries conforming to the UL 2849 standards can be safely stored on a bench top or stored on the bike while on the sales floor or overnight?
This does get into the mechanics of the failure. There are a number of things that will cause a battery pack to fail. Generally speaking, the standards are excellent, and the standards speak to the quality of the pack and the quality of the battery management system, which is critical. And they are tested in a controlled environment to make sure that the pack in and of itself is of a robust design. But some of the flaws that can happen during the manufacturing process are random. You can test 100 packs. The 101st pack may have a defective cell. So the standards are important, and we wholeheartedly encourage dealers to ask their suppliers to provide the documentation that indicates that those batteries do in fact comply with all of the relevant standards. UL has just promulgated a standard that talks about it. I've got it here. It's UL 2849. People for Bikes has made a big deal of the fact that there is now a US-based voluntary standard. Maybe it shouldn't be voluntary, but it goes through all aspects of an e-bike, all aspects of the electrical system. But the reality of it is a defective cell can be produced, even in the finest battery cells that are manufactured. Until we get to solid state batteries, we're going to have to live with that reality. So I maintain that adherence to the standards, compliance with the standards is a wonderful thing. It's not a guarantee. Mm-hmm. So we should, in the e-bike battery pack or e-bike retail environment, I would not rely on that.
Is there an optimal room temperature, Mike, to charge batteries?
No, not necessarily. You don't want to do it in an overly hot environment. The battery pack manufacturers and the cell manufacturers will recommend a temperature range. And that's the beauty of a lithium-ion battery is it's very tolerant of temperature variations as long as they stay below a certain threshold beyond which you've got problems. But that threshold is like 150 degrees Fahrenheit. So charging any battery pack, the cooler the better. It's easier on the pack, it's easier on the charger. But there's no range of battery or there's no range of temperatures that a normal consumer or shop is likely to encounter that would preclude charging a battery. One thing that's important is a lot of times people will go out for a hard ride. I do a lot of e-bike testing, obviously, and I'll bring my bike back in after a hard ride, and the pack itself is hot. Now, you're pulling a lot of power out of that. They're pulling a lot of energy out of that, and the pack itself will heat up. I can plug the charger in immediately afterwards, but the charger and the BMS technology is so sophisticated that it will not allow the charging process to begin until after the battery pack reaches a certain temperature threshold. So that's one of the safeties that's built into the system. And I don't intend to minimize that. I mean, the battery cell manufacturers and the battery pack assemblers go to great lengths to make sure that these packs are safe. There's a lot of technology built into those microprocessors, but the point is you can never rely on anything. That's why you should always take these precautions.
Okay, Mike, we have several questions rolling in, so I'm going to keep going.
Okay.
Have you seen fires occur in new uncharged batteries?
Yes.
Okay. And when we talk about the bucket, will a lid help with the bucket?
The lid only helps in terms of keeping stuff out of the water. I have a lid on my can, but it just, it keeps dirt and debris out of it, and a chunk of a chlorine tablet keeps the water from, growing mold or whatever. So I think a lid is a good idea. Will it help mitigate a fire in the event you put a battery pack that's in a thermal runaway condition in there? It shouldn't really matter. In fact, it's probably better to leave it vented in the event that any hydrogen gas does escape from the chemical reaction between the burning cell and the water. So it would be better to let any gases vent from the can.
Mike, can retailers use sand instead of water in the bin?
Sand, as I say, the purpose of the can and the purpose of the water in the can is to cool the other cells. You could shove a pack into a pile of sand and it's not going to do anything to cool cells adjacent to the failing cell. So sand might preclude rapid, widespread propagation to anything else, but the sand is not going to stop cell-to-cell propagation. So the battery pack will at some point become fully engaged. At that point, it'd have to be a lot of sand to prevent propagation outside the battery pack. So I strongly recommend water.
Okay.
As a cooling medium.
Yeah. Should retailers proactively reach out to their local fire department, let them know that there's significant quantities of rechargeable lithium-ion on site?
Yes, definitely. In some localities, I think it's a requirement. I worked for Pedigo for a period of time, and at Pedigo we were very proactive with these things, and we notified the fire department. They came out, did an audit. We had cabinets. I mean, Pedigo obviously at any given time will have a lot of batteries in storage. Each and every one of those battery packs is in that cabinet unless the bike's being ridden or getting ready for shipment. So it doesn't hurt for the fire department to know that you are a retail outlet that is at any given time storing a quantity of lithium-ion batteries. It never hurts to let the pros know what's going on.
Yeah, Mike, sorry, I'm just going to keep firing them at you here.
That's what we're here for.
Several bikes have internal batteries, not easy to remove, not designed to be charged outside the bike. What are your recommendations there?
That is a conundrum, Heather, and we've talked about this a lot. In an ideal world, that wouldn't be, but we know and appreciate that is in fact the case. I don't have a good recommendation for that. I guess is the fact that you maintain the cardinal rule, never charge it unattended, and you just make sure that the batteries or the bikes are in an area where there's not a lot of flammable materials nearby in case something does happen. But you raise a very, very important, a very, very a critical issue that I don't have an answer for, to be quite frank, other than don't charge it unattended. leave the bike in a place where there's not a lot of adjacent flammable materials. Again, I can't emphasize enough that the likelihood of this happening is low. And isolating the bike away from anything that could catch is good practice, and then never leaving it charged unattended.
And Mike, back to the trash bin, clarification, are we suggesting a metal trash bin or a plastic one?
I use a plastic one because I think there's a sufficient quantity of water in there to cool the balance of the pack until such time as the cell and thermal runaway burns itself out. So I don't think one way or another that would be a big deal. If you try to put a fully engaged battery pack in that trash can, it could be an issue, but if there's a fully engaged pack, you're not going to be able to handle it anyway. If it's on the rack, roll it outside and let it burn itself out. So again, my philosophy is that if you intervene soon enough, while it's only 1 or 2 cells that are in thermal runaway, you get that in the garbage can. That's good enough. But if it's a fully engulfed pack, get it outside.
We've seen some lithium-ion battery fire blankets advertised as a proven containment method. What are your thoughts around those?
Again, the whole purpose here is to mitigate the consequences of a fire. A blanket's not going to put it out. But if the blanket is robust enough to contain it, as I say, these fires are hot. And if it's a big battery pack, if it's like one of these 14S 5P packs with 70 cells in it, it's going to burn hot and it's going to burn for a long time. Anything to mitigate the occurrence until the fire department can get there is a good thing. So if you can slow it down, great. I've not had any experience with some of these blankets. There's also some material available. We talk about battery recycling and all the work that people for bikes are doing. I've had some conversations with the Call to Recycle people about their practices in terms of shipping end-of-life battery packs or defective battery packs. And they have a material that supposedly helps absorb the energy of a burning pack. Whether or not that's enough remains to be seen, I guess. So anything you can do to slow it down until the fire department gets there is a good thing.
Yeah. Is there any risks around uncharged batteries having safety issues, or is there anything we should be thinking about keeping?
That's an interesting question, and because one of the failure modes of a lithium-ion battery, and again, getting a little scientific here for a minute, there's a propensity for what they call dendritic cell growth in the electrolyte if a battery gets too deeply discharged. In fact, battery management systems are programmed that if a battery pack is left in a discharged condition for so long that the natural internal resistance of the battery pack pulls the cells down below a certain threshold, the battery pack will not allow it to charge. You can plug the charger in and it will not turn on because the BMS intervenes. The reason for that is when a cell is so deeply discharged, there's this propensity for dendritic cell growth. Dendritic cells are crystals with very sharp points. It's called, dendrite is Latin for tree, because these little spikes come off these cells, and the spikes are sharp enough and they're robust enough to penetrate the separator. The separator is a membrane that isolates the anode from the cathode. It's semi-permeable in that ions can transfer one way through the semi-permeable membrane. The way a battery works is the ion holds an electron, and when it's charged, the ions travel in one direction for the discharge reason. When it's recharged, they go in the other direction. But a dendritic cell has the ability to penetrate the separator. If it penetrates the separator, it becomes a direct short, and that's what will lead to a thermal runaway. So there is a chance that if a battery is too deeply discharged, it can short circuit and go into thermal runaway. The good news is there's not a lot of energy left in it anymore, so the fire will be minimal. But it is possible for a completely discharged battery to still catch fire due to this mechanism, dendritic cell growth. So even if they're discharged, if there's residual energy, there's an opportunity for that energy to be released in an uncontrolled fashion.
Such fantastic information. And if everyone can look at just the chat, there's some great questions asking for what you're doing, what your solutions you're doing in your store. Mike, thoughts on, we had a question come in from Steve Collins. thoughts on having a timer connected to your battery charging power strip so it only charges during business hours? Pretty cool idea, right?
Yeah, that's a great idea.
And
Because that takes the human element out of it. But even that's fine, and that's a great step in the right direction. But there still needs to be somebody that will proactively move it from the charging card into the cabinet before they go home.
And is it a good idea if you do have a fire, call the fire department right away, or to assume that you could maybe contain it and move it outside?
At the first indication that you've got something going wrong, call the fire department. I mean, like I say, the steps that I outline are intended to intervene as quickly as possible to minimize the damage. At the end of the day, if you're not successful and you call them 20 minutes after this starts, the damage can be a whole lot more severe than it would have been otherwise. I would be on the, again, I think about this a lot. What would I do first? I guess what I would do first is to try one of these mitigation strategies, get it in the water, get it outside. If you're in a shop with more people there, yell at somebody to call 911. But under every circumstance, if there's a failure in process, call the fire department. Those guys don't mind. They would rather come and intervene sooner rather than later. So there's no reason not to call the fire department.
Mike, just flipping over to manufacturers for a minute, is there any certification that the battery or battery manufacturer should have so we know that this is a safe battery? Does anything?
Yeah, there are a number. There's a UN standard, UN 38.3, and battery pack manufacturers submit their battery packs to these agencies for testing to make sure that they comply with UN 38.3. There's a European standard, EN 15194. It's the same protocol. UL has got a standard out. All of these involve testing and certification, and they put the pack through its paces. They do a lot of things to test the integrity of the design and the quality of the cells. But if 1 in a million cells are manufactured and they incorporate a defect, a defect could be a foreign material on the separator as the donut, as the cell is being rolled. Anything that causes the integrity of the separator to be compromised can and will lead to a battery fire, and it could be a 1 in a million defect. And if you're unlucky enough to get that one cell that manifests that defect, you better hope that it's in a cabinet if and when it fails.
Yeah, Mike, we just had one of our P2 profitability group meetings and a question came up and this something similar in a chat here. All these bikes being bought on Amazon, new cyclists coming at us at all different directions. These bikes are being rolled into our bike shop at possible low quality or unknown e-bike manufacturers. Do we even allow them in? Any suggestions there?
Heather, this is a major issue for human powered solutions. We talk about this all the time. In my experience, and it's pretty extensive, in product development, designing new bikes, I've found that typically speaking, the OE cost, this is the original equipment manufacturer cost when Giant or when Fairley or when an e-bike manufacturer buys a battery pack from a battery pack supplier, generally speaking, that pack will cost between $220 and $270, but depending on the capacity and the size of the pack and any accessories like CAN bus that might be integrated into the pack. Now we're seeing bikes with FOB prices lower than $500. I mean, how can you sell a bike? How can a manufacturer sell a bike for $500 without compromising the quality of the battery pack? It worries us a lot. I don't, I was quoted in the Brain article talking about cheap Chinese cells. I don't mean to imply that, Chinese battery makers don't know what they're doing. There's certainly a number of very high quality Chinese battery pack manufacturers. But in my experience, they are less safe, if I can say that, than a cell from, say, a Panasonic or an LG Chem. I've got a lot of confidence in those other companies. I advise my clients, if we're developing a new e-bike, that we will use cells from either LG Chem, Panasonic, or Samsung, because those are the best. So, I mean, when you've got a cheap e-bike, I've got to worry that the quality of the battery pack has been compromised to lower its price. I mean, there are a lot of distributors, for which price is more important than safety. And in the event one of those bikes rolls in your store, I'd watch it closely. Again, this is not meant to be an indictment of some of these low-cost e-bike distributors, but it sure gives us pause for concern.
Yeah, and Mike, I don't know if you'll know the answer to this, but say a battery is destined to go on fire. Is it going to happen early in its life, or could it happen even years later? Should we be concerned not just about newer batteries, but things that are a little bit older as well?
I would suggest that generally speaking, if there's a gross defect in the cell, it'll happen sooner than later. If there's a contaminant on a separator, the separator will be compromised, a short circuit is likely, and when that happens, you've got a fire. But as I pointed out, this dendritic cell growth can happen anytime. Especially if a pack, even a new pack, if it's deeply discharged and it's not recharged, dendritic cell growth can occur, which can lead to separator penetration and short circuit. So there's no hard and fast rule that we can adopt that says, okay, well, if they're new batteries, then I don't have to worry about them. I know of one particular company that sells very expensive e-bikes that had a whole container consumed of brand new bikes or brand new batteries, I should say, that were on their way to the US for distribution. There's no hard and fast rule. There's nothing to hang your hat on that says that, oh, okay, well, I don't have to worry. You do have to worry. You won't have to worry when solid state batteries become available because they won't burn. But in the meantime, as long as we're using a liquid electrolyte in lithium-ion batteries, there's a flammable component. If there's the possibility that a short can occur, that flammable component will generate a fire.
And so everyone who's still here listening in and putting comments in the chat, thank you. Rochelle has also posted in the chat around 1:43 p.m. the written out guidelines for safe storage and charging provided to us by HPS. So you'll want to definitely click on that link and make sure you post those or have those in the shop. Mike, just a couple more questions here that came in that I think are great if you would entertain them. There are specific cabinets designed to suppress fires. Is this an ideal solution in your mind?
It's a very important solution. Nothing is ideal. I mean, there are downsides to putting all your inventory in one cabinet. There's another issue. I'm currently in conversations with UL and the Chicago Fire Department about this. One concern that I have is there a limit to the quantity of batteries that we should store in a cabinet? Because if a fire occurs in one cell, it propagates to the rest of the batteries in the cabinet. If there's too much energy in there, it could be that the fire is so severe that the cabinet will ultimately breach. So my concern is how big a cabinet do we need? And maybe we don't want big cabinets, we want small cabinets so that at worst, only a few battery packs get engaged. So, but anything is better than nothing. Anything that you can do to slow that down until the fire department can get there is a step in the right direction. In conversations with UL maintains that we need to have explosion-proof cabinets. I disagree. Lithium batteries don't explode like a hand grenade. They cook off, and the fire propagates rapidly, but not explosively. So we don't have all of the final answers to that question, except to say anything is better than nothing. Anything that you can do to slow it down and contain it until the pros can get there is a good thing.
Yeah, definitely. And the recording of today will be available in our YouTube channel later today. So anyone who's listening who maybe wants their staff to listen in and share it, that'll be there later today. Mike, I'm hopeful you're going to keep us advised as we move forward.
Definitely, Heather. And again, let me reiterate the one point you're getting sick and tired of hearing me say. E-bikes are not dangerous. Lithium-ion batteries generally are not dangerous, but once in a while, a defect will manifest itself, or damage will manifest itself. If you're prepared, if you can mitigate the consequences, you're in a whole lot better situation than you would be otherwise.
Mike, I have one more, and it just came in, and I love this question I want to ask you. What are we recommending to our customers for storage and charging?
Never charge it unattended. Never charge it. The best thing to do to charge it would be charge it on your garage floor. Beyond that, one bike, one battery and one bike on fire, as long as it's not stored under a pile of some flammable material, will not, it won't be as catastrophic as it would be in a retail environment where you had a lot of bikes and a lot of fire, or a lot of bikes and a lot of batteries. So advise customers, charge it when you're there, charge it, have a smoke detector handy. Because, and again, the likelihood is so minuscule that the chances of it happening are slim. But if they do happen, as long as you're aware and can react, you're in good shape.
Yeah, Jenny, anything you've been listening along here? I see you're busy at work over there. Anything you'd like to add in closing?
This has been great, really fascinating. I'm just taking wheels apart. I've got a wheel building class tomorrow. Just trying to do more things at once. Yeah, I think from the mechanics perspective, having as much knowledge as possible distributed about all of this. So we'll follow up with something to our membership for sure about this. Education is one of the things that we do, and so we'll definitely be looking to incorporate some kind of education component in the coming year with all of this, and of course going forward. So, whatever we can do to help people be safe and knowledgeable.
Thanks, Jenny. Yeah, Mike, anything add? If people have additional questions, is there a way to get in touch with you or?
Sure. Mike Fritz at humanpowersolutions.com.
All right. Well, thank you everyone who took time out of your day to join today. Jenny, Mike, appreciate you both so much. On the NBDA website, we do have a webinar on December 1st with People for Bikes and Call to Recycle on the battery recycling program. Keep looking forward. We'll have a monthly webinar on an e-bike specific topic, and I'd love to bring Mike back and Jenny back to follow up on this. Thank you so much. I hope everyone has a great day and enjoy the rest of the afternoon.
Thank you, everyone.
Thanks, Mike. Thanks, Heather. Thank you, everyone.
Bye-bye.